This is a quick follow-up to the last video where I showed leveraging an Arduino Due to cache the BIOS for my 286 system, pulling it from my PC down to the flash memory built into the Arduino Due. A user PVC on my YouTube channel asked a really good question about the lifespan of that flash memory, and am I really generating a lot of I/O and burning that up, basically? Am I degrading the life of it? A really good question. So I had done some cursory research prior to taking that approach, and from that I wasn't overly concerned. One of the things I was doing in my previous code, and I'm going to show some updates today I've made, but my previous code I was checking byte by byte, did the value actually change, and only if it changed did I do the write operation. And so that was cutting it down. So for 80% of my BIOS image, it was skipping all the writes, so that cut that I/O down. But PVC's question, or kind of statement was that, if I write a single byte within a page, that whole page has to be written. So if I end up writing 10 bytes to a page, byte by byte, I'm rewriting that entire page 10 times. So that ends up being a lot more, writes or cycles of that memory than maybe I could have. So I dug into the datasheet a little bit for this processor on the Arduino Due, and the datasheet says it minimally is going to handle 30,000 cycles of that flash memory. And that sounds like a decent number, but I think it probably does add up if I'm doing a lot of this updating of BIOS as I go. And everything I've read is those numbers are very conservative. So maybe I'd get 50,000 out of it. Maybe I'd get 20, who knows? But they're listing it as a conservative 30,000. Something else I looked up in the datasheet was that the default page size is 256 bytes. So if I write a byte, it's actually writing 256 bytes physically at the flash, if I understand that correctly. So let me maybe show you what I've done here to make this better. And if I look at my code, I'm going to pull up and just show you a comparison of what I had. So the left-hand side of this code is what I had for functionality, and I'm just going to go down to the loop. And in the loop, where this is the code from the last video, I check that is there something coming in on the serial USB. If there's at least a byte, then I continue down and I read that byte, actually right here on line 215. So I read the byte. And then once I read it, I compare it to what's actually on the flash. Those reads aren't costing any lifespan, so that the reads are fine. And I compare it, and only if it changed do I then do a write. And that's where the tricky part is. That's actually going to end up writing a page based on what I'm understanding as I've researched it as a follow-up to PVC's question. So that's what I want to get rid of, is that single byte write call. And so over here, instead, what I'm now doing, this is the updated code, I am going to wait until the serial USB has 256 bytes available. So I have a buffer size set up, and you can see it's set to 256. And once I get 256 bytes of stuff incoming, ready to go, then I'll actually go in and receive it. And I'll receive all 256 bytes at once from the serial USB. I then iterate through those 256 bytes and compare them to their corresponding bytes on flash. And if any one of them has changed or is being requested to be changed, I flag that page as dirty. And basically, I'm doing 256 byte operations now. If all 256 bytes are the same, then I can skip that page. I don't need to do any writes to the flash for that page. But if it does find something that changed, now this dirty flag is true, and if it is dirty, then I go in and I write. But instead of writing a single byte like I had over here to the left, where I just said write and it was write a byte, just one byte, now I'm going to write, and I'm going to write 256 out of this buffer of 256. So I'm going to write all 256 at once. And as I dug into the library I'm using and the library underneath it that it's using, it seems like on the back end, it does some optimization to do page level type of updates. So this, my thought is okay, now this should be updating a page only if the page needs to be updated, and only make one pass through the page, and not, if I update 10 bytes in a page, it doesn't update the page 10 times. It just does it once. And then I increment that I process 256 at a time, and if I end up getting to my byte count, I'm done. So that's what this code is now doing. And if I look over here, I'm going to just clear my serial output, and I'm going to reset my Nano real quick. And you can see that it's all Fs right now. This code has already been programmed to it. It's all clear. It's all Fs. But I'm going to pull up that utility that I use to actually send the image, and I'm going to connect to the Nano, and I'm going to go ahead and do a transfer. And so transfer started. And if you watch the last video, if I did a full image update, which is what I'm doing right now, it took over 2 minutes, 2, 3, 4 minutes, depending on what I was doing, but around, let's say 3 minutes. With this update that I just made, doing this 256 bytes at a time, I'm now down to 20 seconds, and that is great. So now I can do a full image update at 20 seconds. So I'm going to disconnect for a second. I'm going to reset my Arduino so that we can read what's there and just validate, does it look right? And I look through that, and it's, yep, these match. This is the first 16 bytes, the last 16 bytes, and that all looks good. And I might be making a bad assumption, but the assumption is that the stuff in the middle also is fine. I'm just spot checking the beginning and end, and if that all turns out okay, I have some confidence it seems to be working okay. So now I'm going to reconnect, and I'm going to do the transfer again. And this time there shouldn't be any updates at all on the BIOS, but I just want to compare, is it any faster? And it was 20 seconds for the full image. And then here, I'm only doing writes if there's changes, and there's no changes. So this should end up with no writes being made at all to the flash. And you can see it's essentially the same speed. So I think PVC's question was very helpful, and in this case I was writing pages way too many times, and now with those pages being written properly, the bottleneck is not the writing of the pages anymore. It's just maybe general transfer and other processing that's going on here. But I now have a 20-second full cache refresh on that Arduino Due's flash memory. And so that is great. And in this case, if I go into my 286 code and I make a minor change and I build it and I go to update it, it's just updating the pages that actually had changes, and it's doing page level. So all around, this seems like a really nice improvement to my code, and I'm fine with where I'm at as far as, do I think this is am I going to burn up the life of that flash memory quickly? I think with this current build, I'm feeling okay that this isn't such a concern. So if every time I do one of these page updates, and I'm doing a page at a time and not multiplying like I was doing before, so if I update my BIOS 10 times in a day, that's me burning up 10 of those cycles a day. And so to get to 30,000, I don't think is going to happen. And worst case, if I do find that my code wasn't doing it right, or the libraries supporting my code aren't optimizing it well enough, I might lose the top 256K of flash in my Arduino. And I can still use the Arduino at that point, not for the same purpose, but I would now be down to 256K out of the 512K. So I'm not worried about losing the Arduino, but I might lose the upper, 256K of flash if I was truly going to hit a limit. But I think with this update here, I should be okay. So that is it for this update. Next update will be a normal, larger update where I'll do the full system BIOS update from beginning to end and just show how that all is working.